Hello, welcome. Let's try to solve another Leetcode problem 208, implement trie. So for this problem we are giving a class. So this class we're gonna call it a trie, and it has such kind of method. It has the insert, search, and start with. So for this insert, we just need to insert a word into the trie, and for the search, we just need to search if there is a word inside this trie. If there is, we're gonna return true, otherwise it's gonna be false. And for the start with, it's gonna be a prefix. So for example, inside of the trie, if this is the root node, it coming for A, B, C. Yeah, so for A, B, C, this is a word. So for search, it's gonna be true. And if it is a prefix, so for example, we're gonna check AB. So AB is a prefix, so it's gonna be true. But what about AD? So there's no AD, so AD is gonna be false. For this prefix and for the search, it's gonna be false. Yeah, so we should know that if the start with is false, definitely the search is gonna be false. Yeah. So basically for a trie, it has the basic information, basic method. It is insert. Definitely we can insert any word inside a trie. Yeah. And similarly, we can use the same code for the search and the start with. It's going to be exactly the same. So this is not a difficult problem if we understand what is a trie and how to write the trie data structure. So let me just write it. So we're gonna define a trie node because if we were to implement the trie, we need a trie node. So self.children gonna be a dictionary, and self.add of a word gonna be false. Yeah. Now for the init, we're gonna prepare a root. So self.root gonna equal to trie node. So we're gonna use this trie node. Yeah. And for the insert, we're gonna insert from the current root. So the current gonna equal to self.root. Yeah, and we just need to check for any character inside the word. If this character is not inside the trie, so the trie gonna be current.children. If it is not inside, so we're gonna prepare it. So current.children with this character gonna be a trie node. So otherwise, if it is inside, so we're gonna update the current. So current gonna equal to current.children with this character. So finally, we're gonna prepare the add of the word because this is insert. So at the end, it's gonna be true. Yeah. And similarly for the search and start with. So let me just copy the same code. So we're gonna start from the current. If this is inside the word, if this is not inside current.children, if it is not inside, so definitely we can return a false. So otherwise, we gotta continue to check and to at the add, we need to return current.add of word. So if this is true, so it means we found this word. If it is false, it means we didn't find. It is just a prefix. Yeah. Now we just copy and paste the code for the start with because, as I said before, it's exactly the same. Yeah. So for the prefix, so we just need to change this word to prefix. If this is not inside, so definitely it's going to be false. Otherwise, we're going to continue to check until we go to the add. So definitely, if we can go to the end, it doesn't matter if the add of the word is true or false, we're going to return a true. Yeah. So this is also implementation of how to use a trie. And the trie is also called a prefix tree. So the method is we're going to prepare a trie, and we're going to use the insert, search, and start with to check if everything is okay. Yeah. Now let me just run it to check if it works. It seems it didn't work. So where it is? Yeah. So self.children. Yeah, because I didn't prepare the init. Let me just prepare the init. I forgot to prepare the init of the class. Yeah. Now let me just run it. Now as you can see it works. Now let me just submit it to prove that it can pass for all testing cases. As you can see, it passed for all testing cases and it's pretty fast. And for the time complexity, we can analyze any kind of insert, search, or start with. So for any of the methods, so for example, if this is the insert, it depended on how many words. So currently, if this is just for this word, so for example, if I have a word, the length of the word may be 100, or maybe 10. It depended on the length of the word, and then if it is not inside, I'm gonna just insert it. So as we can see, it is just depended on the length of the word and the number of the word. So the length of the word times the number of the word. So let's just check. Oh, it's gonna have such kind of a cause, and the length of the word gonna be this. So the time complexity gonna be 2000 times 3 times 10 to the power of 4. Yeah, I think that's all about it. Thanks for watching. See you next time.